Recently, a discovery has captivated the attention of scientists and space enthusiasts alike. Bill Nye, a well-known science communicator, made headlines when he announced that Voyager 1 had detected 300 massive objects in space. This revelation has not only ignited our curiosity, but also raised profound questions. What exactly are these objects, and where do they come from? Join us as we delve into the mysteries hinted at by Voyager 1's astonishing findings. For nearly 5 decades, the Voyager missions have provided some of the earliest and most extraordinary views of our solar system's wonders. Surprisingly, these missions weren't designed to last this long. Back in the 1970s, Michael Minovich had a groundbreaking idea. A spacecraft could use a planet's velocity to propel itself further into the solar system. Originally intended to last only 5 years, the Voyager mission has far exceeded those expectations. Launched just weeks apart in the summer of 1977, Voyager 1 and Voyager 2 were first tasked with exploring Jupiter and Saturn. They accomplished this by providing detailed studies of these gas giants. But the journey didn't stop there. Voyager 2 went on to conduct the first-ever close-up observations of Uranus in 1986 and Neptune in 1989. These historic flybys of 4 planets earned the mission the title Voyager Grand Tour. Instead of ending, the resilient spacecraft set their sights on a more ambitious goal, exploring deep space. Now, 46 years later, both Voyager 1 and Voyager 2 are still traveling and collecting crucial scientific data from the distant regions of the cosmos. In 2013, NASA made a groundbreaking announcement. Voyager 1 had officially entered interstellar space, the region between stars, beyond the sun's magnetic fields and particle influence. It's like leaving the busy solar system and stepping into a serene, star-filled wilderness. This journey continued in 2018, when Voyager 2 also crossed into this vast region, located 17.7 billion kilometers from the Sun. Astonishingly, Voyager 1 and 2 remain the only spacecraft to have ventured into interstellar space, where they study how the interstellar medium interacts with the solar wind from our Sun. These pioneering missions have been our primary source of information about the heliosphere, a protective bubble that surrounds and shields our solar system. The heliosphere, shaped and influenced by the solar wind, a continuous stream of charged particles from the Sun, acts as a protective barrier for our solar system. Both Voyager 1 and Voyager 2 have served as our cosmic messengers, relaying valuable information about this celestial shield. All of this data converges at the heliopause, the outermost boundary of the solar system, marking the transition between the solar wind and the vastness of interstellar space. NASA's Voyager spacecraft has given us new insights into interstellar space. One significant discovery is that cosmic rays, mysterious high-energy particles, are 3 times more intense beyond the heliopause than within the safer confines of the heliosphere. It's like comparing the calm of a quiet backyard to the busy energy of a bustling street. But there's more to this cosmic story. NASA didn't stop with the Voyager findings. By combining data from later missions with Voyager's observations, they created a more complete picture of how the Sun interacts with the surrounding interstellar space. In this grand cosmic dance, scientists made an unexpected discovery. In 2023, Voyager 1 detected a faint, low humming sound that corresponded to the vibrations in small amounts of gas, drifting through interstellar space. Nicola Fox, head of NASA's Heliophysics Division, emphasized the importance of the Voyager missions, stating that over the past 46 years, they've provided invaluable knowledge, transforming our understanding of the Sun in ways no other spacecraft could. This incredible adventure in space is even more impressive considering the Voyager's power limitations. Both spacecraft are powered by a plutonium-based system. However, as the plutonium decays, it generates less heat, gradually depleting the spacecraft's energy. To cope with this challenge, NASA has had to make difficult decisions, shutting down non-essential systems, even heaters designed to keep instruments warm in the freezing void of space. Astonishingly, despite these challenges, all 5 key instruments have continued to function since 2019, defying expectations. NASA scientists remain baffled by how the Voyagers are still operating under such cold conditions, where other spacecraft would freeze. This mystery adds another layer of awe to the legacy of these remarkable space pioneers, whose journey continues to surprise astronomers and deepen our understanding of the farthest reaches of our solar system. The heliopause, which marks the boundary between the sun's influence and interstellar space, isn't static. Instead, it's shifting and forming unusual angles, leaving scientists both intrigued and perplexed. The idea that the heliopause might change shape isn't entirely new. Over the past decade, researchers using data from Voyager 1, Voyager 2, and NASA's Interstellar Boundary Explorer (IBEX) satellite have observed its tendency to shift. These spacecraft provide crucial direct measurements of these cosmic boundaries, even if they can only capture a snapshot of a single location at a specific time. Dr. Eric J. Zarin, a space physicist from Princeton University, shared his excitement in an email to Vice, noting that IBEX has been supplying valuable data, helping scientists refine their predictions about the heliopause's future movements. What makes things even more intriguing is that recent studies have challenged long-held assumptions. In 2014, IBEX detected an unusual brightening of energetic particles, hinting at irregularities in the heliopause. However, these anomalies didn't fit current models, almost like an unexpected twist in the story. Researchers also noticed substantial shifts in the heliopause's position over a short period. This may explain why Voyager 1 entered interstellar space in 2012, followed by Voyager 2 in 2018, despite the 6-year gap. These surprising findings aren't just puzzling. They also contradict what scientists thought they knew about the heliopause. In a recent article in Nature Astronomy, researchers described these discrepancies as entry-speaking, indicating that they raise questions and could spark debate within the scientific community. But the search for answers continues. NASA's upcoming Interstellar Mapping and Acceleration Probe, IMAP, scheduled for launch in 2025, promises to uncover more secrets about the outer edges of our solar system. Meanwhile, the mysteries persist. On May 2023, Voyager 1 experienced an unusual event during its operations. The spacecraft's Attitude Articulation and Control System, AACS, which manages the direction of its high-gain antenna, began sending back confusing data. Instead of the regular updates on its health and status, it seemed like Voyager 1 was struggling to communicate, almost as though it were experiencing something akin to electronic aphasia, a kind of communication confusion. From Earth's perspective, it appeared that Voyager 1 was encountering electronic difficulties. The data Voyager 1 sent back during its recent anomaly seemed random and incoherent, as NASA described at the time. Interestingly, despite these strange reports, Voyager 1 itself appeared to be functioning normally. Its radio signal remained strong and stable, indicating that the antenna was still pointing towards Earth, contrary to what the Attitude Articulation and Control System, AACS, was suggesting. Adding to the mystery, Voyager 1's scientific instruments continued operating smoothly, unaware of the AACS malfunction. Even the spacecraft's fault protection system, designed to place it into safe mode in case of issues, was not triggered. Fortunately, NASA quickly discovered the problem. The AACS had been using a computer that had been inactive for a long time. The solution was straightforward. They sent a command to switch to a functioning computer for data transmission. However, the cause of the AACS's strange behavior remained unclear. NASA speculated that an incorrect command from another onboard computer might have caused the issue. While this event didn't endanger Voyager 1, NASA continues to investigate to prevent similar problems in the future. Voyager 1 has been exploring interstellar space for over a decade, outside the protective magnetic field of the Sun. This field, like Earth's magnetic shield, protects the spacecraft from cosmic rays and radiation, acting like a cosmic suit of armor. As with technology on Earth, Voyager 1's onboard computers occasionally face challenges from high-energy particles in space. Sometimes these energetic particles can interact with computer chips, causing small memory errors that accumulate over time. Susan Dodd, project manager for both Voyager 1 and 2, offered a broader perspective on these challenges. She explained that encountering such anomalies is expected at this stage of the mission, given that these spacecraft have been on an extraordinary journey for nearly 5 decades, far exceeding their original mission timeline. Now navigating the uncharted territory of interstellar space, where radiation levels are high, the Voyagers face a range of cosmic hurdles no other spacecraft has ever encountered. Nearly 50 years have passed since Voyager 1 and Voyager 2 embarked on their historic journey, crossing immense distances and exploring the unknown. Despite their 1970s-era computer systems, which operate with just 70 kilobytes of memory. Yes, only 70 kilobytes. NASA has kept these distant explorers running. Just imagine the effort involved in sending software updates across vast cosmic distances. Ensuring the ongoing operation of the Voyager spacecraft is like providing cosmic IT support. Amid the vast darkness of space, billions of miles from Earth, these legendary probes continue crossing major thresholds, offering profound insights into the mysteries of our solar system. Let's take a moment to appreciate these trailblazing pioneers, the twin Voyager probes. Now drifting endlessly among the stars, each Voyager is about the size of a small car, representing the technological spirit of the 1970s. Despite their outdated computer systems, which are less powerful than today's digital watches, and their analog TV cameras, which seem primitive compared to modern ones, the Voyagers have left an indelible mark on every celestial body they've explored. Thanks to these spacecraft, we've uncovered astonishing details about the planets they visited. For instance, Jupiter was revealed not just as a calm giant, but a world of extremes with hundreds of fierce hurricanes, a glowing aurora at its north pole, and intricate rings. Saturn, once thought to have a few simple rings, was discovered to have thousands of delicate ringlets with braided structures previously considered impossible. Even more shocking was the discovery of active volcanoes on Jupiter's moon Io and Neptune's moon Triton. On Triton, nitrogen geysers were seen erupting at temperatures near absolute zero. Perhaps most exciting of all were the revelations about potential alien life. Two moons, Jupiter's Europa and Saturn's Enceladus, were found to likely contain vast salty oceans beneath their icy crusts. Oceans that could potentially harbor life, making them prime targets for future exploration. Voyager's most poetic moment came in the early 1990s, when it took a final look back at our solar system. At the suggestion of Carl Sagan, one of Voyager's key visionaries, the spacecraft captured the iconic image known as the pale blue dot, a view of Earth from 100,000 times farther away than any human had ever seen. This humbling image was meant to remind us of our small place in the vast universe. In 2012, Voyager 1 made history by crossing into the interstellar medium, over 11 billion miles from the Sun. Voyager 2 followed in 2018. These spacecraft are now so distant that it takes 22.5 hours for a radio signal from Voyager 1 to reach Earth, and nearly 19 hours for Voyager 2 to reach Earth 2. They continue their journey, moving another 3 to 4 light seconds away each day. NASA's Deep Space Network, with tracking stations around the world, ensures continued communication with these distant explorers, even as Earth spins. However, as the Voyagers venture further into interstellar space, their signals become faint whispers amid Earth's noisy backdrop of radio waves and technology. Despite this, they continue transmitting valuable data, a testament to the endurance and brilliance of the mission. The Voyager mission itself was a stroke of luck. Initially, scientist Michael Minovich discovered that spacecraft could gain speed from planets using gravitational assists. Later, Gary Flandreau demonstrated that a rare alignment of the outer planets in the late 70s and early 80s could allow a spacecraft to reach Neptune in just 12 years rather than 30. NASA seized this once-in-a-lifetime opportunity, though budget constraints forced a scaled-back version of the Grand Tour, originally envisioned for the outer solar system. Nonetheless, nearly 50 years later, Voyager 1 and 2 remain humanity's most distant emissaries, unlocking the secrets of interstellar space. Their legacy will endure for generations, reminding us of the boundless curiosity and perseverance that drive us to explore the unknown. Let me know your opinion in the comments box. If you liked the video, click the like button and subscribe to not miss our next videos.